290 million years after the Big Bang, a galaxy 1.6 kiloparsecs across, stellar mass exceeding 100 million suns, fully formed enough to be recognized as a galaxy, and it should not, according to our standard model of cosmology, have been able to exist yet. The James Webb Space Telescope found it in 2024. It is one of several, and every new observation makes the problem worse. The James Webb Space Telescope, launched December 25, 2021, deployed to the second Lagrange point, 1.5 million kilometers from Earth. Infrared observations of unprecedented depth. Every image it returns is looking back in time. The further the galaxy, the longer the light has traveled, and the earlier the cosmic age we see. Here is the cosmic timeline according to standard cosmology. The Big Bang, 13.8 billion years ago. The cosmic microwave background, the universe becoming transparent at about 380,000 years. Then the Dark Ages, hundreds of millions of years with no light sources. The first star's population 3, emerging around 150 million years. Reionization, completing by about 1 billion years. This was the expected story. JWST is rewriting parts of it. JWST's NIRSPEC and NRCam instruments measure redshift. The redshift tells you how far back in cosmic time you are looking. JADES GSZ14-0 has a confirmed spectroscopic redshift of Z equal to 14.32. That corresponds to light from about 290 million years after the Big Bang. This is the most distant galaxy ever confirmed, and the measurement is precise. Hold that number. 25% of the way through. 290 million years. That is the age of a galaxy. That is the age of light. Here's what should have been there. According to the lambda cold dark matter model, the standard cosmology of the past 40 years, galaxies at this epoch should have been small, dim, and unstructured. Primitive clumps of the first-generation stars forming out of primordial hydrogen. A galaxy with 100 million solar masses of stars at 290 million years old was not predicted. Labbe and colleagues, in a 2023 Nature paper, found 6 candidates at similar early epochs. All of them too massive for the standard picture. Multiple possibilities exist. 1. Star formation in the early universe was much more efficient than standard models predict. The first stars may have been extraordinarily massive, hundreds of solar masses each, burning hot and fast and forming rapidly. 2. Primordial black holes, formed in the very early universe, acted as gravitational seeds that accelerated galaxy assembly. 3. The measurements are somehow systematically wrong, but the JADES team's spectroscopic confirmations make this unlikely. Each explanation, if right, rewrites something fundamental. GN Zelevin, first identified by Hubble in 2016 and confirmed by JWST, is at redshift about 10.6, roughly 400 million years after the Big Bang. Too bright, too massive. JADES 1390 at Z13.2, 325 million years, also problematic. CER's 2112, a barred spiral galaxy confirmed at Z2.1, from when the universe was only 3 billion years old, has a bar structure that models say should have taken much longer to form. The list keeps growing, halfway through, the 290 million years from the opening. Here's what the measurement actually means for cosmology. The tension is sometimes called the impossible early galaxies problem. In the standard cosmology, dark matter halos take time to form, gas takes time to cool and fragment, stars take time to ignite, galaxies take time to assemble. The total time from the first inflation to a galaxy with 100 million solar masses of stars should be on the order of 500 million years minimum. JWST is showing us galaxies of that scale at less than 300 million. Boylan-Kolchin, in a 2023 paper, called the JWST results a stress test for lambda CDM cosmology. The standard model has been extraordinarily successful, explaining the cosmic microwave background, large-scale structure, galaxy rotation curves, nucleosynthesis. But here, at the earliest epochs, it shows cracks. The community is watching to see whether the tension resolves or whether something fundamental needs to change. If the standard model is wrong about early galaxy formation, the implications extend outward. Dark matter properties may need adjustment. Inflation models may need modification. The the role of primordial black holes may need reconsideration. Every correction propagates. The universe's timeline, as currently understood, becomes provisional, subject to rewriting as data accumulates. Our textbook diagrams may be historical artifacts of a moment before we looked carefully. 75% of the way through, the remaining minutes are what JWST is about to keep revealing. JWST has a design lifetime of at least 10 years, possibly 20 with careful fuel management. Every month, new high redshift galaxies are being spectroscopically confirmed. The JADES survey is one of several systematic deep field efforts. CER's Cosmos Web Uncover Primer, each survey extending the census. Each new confirmed galaxy either fits the model better or tightens the tension. The data is accumulating faster than interpretation can keep up. The light from JADS GSE14 Mani-0 has been traveling for about 13.4 billion years. It started its journey when our sun did not exist yet. Earth did not exist. The solar system was 9 billion years in the future. The light traveled across the expanding universe, getting redshifted. Its wavelength stretched from ultraviolet to infrared as space itself expanded underneath it, and it arrived at JWST's mirror in early 2024. Photons that have been traveling longer than most of what exists today has existed. The 290 million years from the opening that number is the age of the universe when the galaxy existed, not when we see it. The light that arrives now is a photograph from a universe that no longer exists in that form. The galaxy itself, if anything remains of it, has grown, merged, or been absorbed into larger structures over 13.4 billion years of cosmic evolution. We are looking at ghosts of a younger cosmos. And they tell us our timeline is at best incomplete. When you look up at the night sky, every distant object you see is an image from its own past. The brightest stars, years. The nearby galaxies, millions of years. JWST's observations, billions. We live in a universe we can only see as it was, not as it is. And our understanding of its beginning is, for the moment, being rewritten every month by an instrument the size of a tennis court, floating 1.5 million kilometers from Earth. JWST continues. Every month, more distant galaxies are confirmed. Every month, the picture of the early universe becomes stranger, not simpler. The standard model is not broken, but it is bending, and the oldest light we have ever detected is telling us something the cosmology of the past half-century may not be ready to hear. Ancient galaxies are being discovered, none of them aware, none of them hostile, just physics. If you had to guess, when we finally understand why these early galaxies formed so fast, do you think it will require new physics or just better models of what we already know? Drop your answer below. The current leading hypotheses are in next Friday's video.